let's talk about how to interpret z-scores. Most of the time, when you're finding a z-score, you don't wind up with numbers like 27. And if you do, double check and make sure you did your math right. It's not impossible, but it doesn't usually happen. Most z-scores are in the range, this is the positive side, most z-scores are somewhere in the neighborhood of -3 to +3. Numbers outside that range could happen, but they usually don't. If your z-score is between -1 and +1, whether it's your height, your weight, your blood pressure, your score on a test, your golf score, anything where we could find a z-score, you are middle of the road, typical. If we're looking at heights, people with z-scores between -1 and +1 are medium size. If you're close to 0, then you are close to average. Anything that is less than -2 or bigger than 2 is probably unusual. If you had a z-score of +2 on a test, that would mean you did really well. You were one of the top students in the class. If your height had a z-score of 2, that might mean that you're more than 6 feet tall. For a guy, more than 6'1", I think. And anything beyond 3 or beyond -3 would be very unusual. There are people who are 6'10". There's nothing wrong with it. It's possible. It's just not very common. So, values that are close to 0 are very typical, very average. What does it mean if your z-score is exactly 0? That you are perfectly average. You are right in the middle. If your height has a z-score of 3.5, you are very tall. You know, you walk into a room and people go, "Oh, hi." If your height has a z-score of -3, you are unusually short. As a matter of fact, if you have a variable where the histogram is symmetric and highest in the middle, if you have a variable where the histogram looks kind of like this, we come across something called the empirical rule. %8% of the population has a z-score between -1 and 1. 68% of people are within 1 standard deviation of the mean. 95% between -2 and +2. And 99.7% between -3 and +3. This is what the empirical rule says. 96% within 1 standard deviation of the mean, 95% within 2, 99.7% within 3. Yes?
Can you say that again? Because you said 96 for the first one.
Ah. So this is the empirical rule. 68% of the population is within 1 standard deviation of the mean. 95% is within 2, and 99.7% is within 3. So this is saying almost nobody winds up with a z-score that's more than +3 or less than -3. People could, but not many people do. And this rule applies anytime the histogram is symmetric and biggest in the middle. We call this a normal histogram, meaning it tends to cluster towards the middle. We will do so much more with this normal histogram. It will come out your ears, but not today. Okay, so why do people find a z-score in the first place? One reason is to compare apples and oranges. Z-scores work the same no matter what you're measuring. You could compare the weights of apples and the weights of oranges. You can say, well, here I got a big apple and here I got a big orange. The apple's bigger, but is it bigger compared to other apples? So, your English test wasn't too terribly hard. The mean score was 83 and the standard deviation was 11.2. Your history test was a lot harder. The average was only 71 and the standard deviation was 14 points. You got an 85 on the history test and a 90 in English. Which test did you do better on? Let's find the z-score for each of those tests. So you got an 85. The mean was a 71, and the standard deviation was 14. So that works out to exactly 1. 7/11.64. So your grade on the English test is higher. But in history, because the average was so low, that 85 means more. You beat out quite a bit of the class. You're a whole standard deviation above the mean. Not many people in history did 85 or better. In English, a pretty good portion of the class did 90 or better. So, in a way, the 85 on the hard test is better than the 90 on the easier test. So now you can compare your performance on a hard test to your performance on an easy test. Assuming, of course, that you know the mean and standard deviation on each test. I find the mean and standard deviation of all my test grades. You should go to all your teachers, and on every test you should make them tell you the mean and standard deviation of all the test scores. No, don't. Then they'll get mad at me.